Good morning, boys and girls. This is our science lesson for today. If you remember last time, we were on lesson 4, which is mixtures and solutions. We're in the middle of E right now. As a reminder, a mixture is two materials that are physically combined. You can have two types of mixtures, homogeneous and heterogeneous mixtures. Homogeneous are the ones, because homo means same, homogeneous are the ones that look the same throughout. Heterogeneous, hetero means different. Heterogeneous mixtures are the ones that are look different. They might be speckled or spotted or cloudy. They just look some way different throughout. A colloid is a material, is something that's not really quite heterogeneous, not quite homogeneous. It's usually a mixture of two different, between two things. It might also be between two states of matter, like between a liquid and a gas, or something like that. A solution is another name for a homogeneous mixture. A solution is always the same throughout. It can be a solid, liquid, or gas. Usually solutions are liquid or gases, but usually liquids, but that's what we encounter. But what should I say? That's what we use oftentimes in science, but we encounter solutions of all types every day. We talked about solute, solvent, and solute, and in a solution. Solute is the thing that goes into a solvent, and the solute dissolves, like salt in water. Obviously, the water doesn't dissolve. The salt dissolves in the water. Salt would be the solute. Water would be the solvent. Solubility was the ability that how dissolvable that thing is, how much of that thing can dissolve in that other thing, how much of the solute can dissolve in the solvent. Once you are full, it's called being saturated. If you get beyond full, once you get to beyond the point you can't put any more salt in and get it dissolved, it will become super saturated. We talked about suspensions. Suspensions, as Cash did a little experiment there, and with oil and water, the oil and the water separate from one another. That's a suspension because they do not mix together, even though you shake them up a little bit and get them to look like they're mixed temporarily. If you just set it down on the counter, they will not mix. We talked about the 4 common types of colloids. We have emulsions, which are a liquid and a liquid. We had an aerosol, which is a gas with little solid or liquid particles in it, so a liquid or a solid dissolved in gas. A gel is a solid dissolved in a liquid. So basically you take a liquid and you put a solid in it to give it structure. And a foam is a liquid with gas dissolved in it. So take a liquid, pump gas in, and gives it a bigger, kind of puffs it up a bit. We talked about different ways mixtures can be separated, and that was lesson 4. Today we're going to be on lesson 5, which is talking all about chemical changes. I don't know if that was backwards or forwards, but let's see. Chemical changes. We're going to be on E70. So before we talked about different physical changes, the big thing from this lesson is going to be, can you tell the difference between a physical change and a chemical change? A physical change can look in a lot of different ways. It can look very different. It changes in size. It can change in shape. It can change in even the state of matter. You can change the state of matter, and it would still be considered a physical change. For instance, if I had this pillow, okay, and I squish it. Obviously, I squish it. That's a physical change, right? The pillow. It still is a pillow. Now, I can obviously easily bring it back. If I can, that's a clear indication there. If I can easily bring it back to what it was, then it's definitely a physical change. Chemical changes aren't necessarily easy to bring back to where they were, and I don't really have anything that I can rip. But pretend I had a piece of paper. I don't have any paper in here. Should have grabbed one. And I rip a paper up into little tiny, tiny pieces. Okay, that would be a physical change as well. Because now you might say it's not easy to be put back to itself, but the key is, what is it? Did it change what it is? It's still paper, right? Another physical change, you could change the state of matter. For instance, a um, this bottle of water. Okay, I have this bottle of water. I put it in the freezer, and what happens? It becomes ice. We discussed before. I forget who it was it Hector? I think it was that put your water bottle in the freezer, and we were talking about how when liquid is very strange, and that when it changes states of matter from a liquid to a solid, usually things shrink, they contract when they become solids. Water is the strange one because water actually expands when it becomes a solid, which is why ice does what in water? It floats. And so we talked about that, how if you put a water bottle in a freezer, it gets like the rounded bottom because all the water is trying to expand outward. But anyway, so you might say, wait, it changes the state of matter. Liquid becomes a solid with water, and it changes what it is. It was water, now it's ice. Well, ice is still water. It's just solid water. It's exactly the same thing. Liquid water, solid water, exactly the same, but they're just two different states of matter. So you can go back and forth between states of matter. All of those that I mentioned so far are just physical changes. Okay? It does not change the essence of what the thing is. So we're going to talk about a chemical change. What a chemical change, it changes what it is. And it's not easy to go back from. It's not easy to reverse a chemical change. Oftentimes it's impossible to reverse a chemical change. And it changes the essence of what the thing is. Excuse me. For instance, now you might not think this changed the essence of what it is, but like when an apple becomes ripe, it goes from a green apple to a red apple, or let's say tomato, because some apples are green all the time. Green tomato to red tomato. When it makes that change, that's a chemical change. Now you might say, but it's still a tomato. Yes, but a ripe tomato and a non-ripe tomato are two different things. And you can't go back from a red tomato back to a non-ripe green tomato. It's not reversible. You can't do it. Another way to think about a chemical change is it's called a chemical reaction. You might have heard the words chemical reaction before. A chemical reaction would look something like what you see on E71. You see that that thing right there is a chemical reaction. Where did I put my marker? I'm all out of sorts here. There it is. I found it. Page E71, that's a chemical reaction. You see the starting substances on the left and the new substances on the right. What that means is those two things in the circles, NaHCO3, which is baking soda, and CH3COOH, which is acetic acid, which is found in vinegar. Those two things in the circles combine together to make H2O, which is water, CO2, which is carbon dioxide, and NaC2H3O2. Okay. Now, if you're not sure, all you do is you have to count what's on each side. So let's go through it. Let me just write it out here. NaHCO3 plus CH3COOH, H2O, CO2, NaC2H3O2. Okay, so I have the reaction right here. Although it's probably flipped for you. Hopefully it's not. But anyway. So you go through and you count. Okay, and you count how many of each. So on this side of the arrow, what do we have? We have, for NAs, how many NAs do we have? We have one, just one NA. Okay, and we look over here. How many NAs do we have over here? We have just one. Okay, so we're good. And you go through like that. Look at the H's. One, so there's one right here, but then it says H3, so that counts as three of them. There's 1, 2, 3, 4, 5. So on this side we have H2O, so that's 2, 3, 4, 5. We have 5 H's. Now let's look at the C's. We have 1, 2, 3 on this side, and we have 1, 2, 3 on this side. And the O's, we have 3, 4, 5. And I have 1, 2, 3, 4, 5. So that's what's called a balanced equation. So let's look at balancing. That one's a little tricky, but let's look at balancing some simpler equations. Okay, let me give you one here. N2 plus H2 and H3. Okay. So, I hope this isn't backwards. Let me see if this is backwards. I don't know, we'll see. Hopefully you guys can see. I feel like the camera flips it automatically, but hopefully it doesn't. Anyway, N2H2, NH3. So you see here, what do I have? I have N2, which is 2 N's on this side, and I only have 1 N on this side. And I have 2 H's on this side, and then I have 1, 2, 3 H's on this side. Okay? So what you have to do is, see these little numbers here, these are, obviously we know these are the elements. These little numbers here are called the subscripts. Sub meaning under, and script is writing, so under writing. They're written next to it, and it tells how many of each of those. There's a little thing that we can do called a coefficient. We can put a number in front of them, and that's called a coefficient. That tells how many molecules. Like for instance, this is an H2 molecule, right? And if we put a number in front, I could have 2 H2 molecules, 3 H2. If I put a 4 in front of it, I would have 4 of those H2 molecules. Okay, if I put like a 2 in front of it, and the 2, let's say I put a 2 right here, or like a 4. Let's say I just put a 4 randomly right there. Okay, that's a 4. Doesn't really look like one, but that's a 4. That's 4 NH3. That means NH3 is a molecule, and I have 4 of them, right? So that means now what I would do is I multiply this number by whatever I have here. So now I have 4 N's, and I have 4. This is H3, so I have 3 H's right here multiplied by 4. That means I have a total of 12 H's, right? But so what I want to do is make sure the total number on this side matches the total number on this side. So I have 2 N's right here. I only have 1 N. So what if I go like this? Okay. Now I have 2 N's here and 2 N's there. Great. But the thing was, you know what I did? 2 N's, 2 times this 3, 2H3. So that means I have 2 times 3 equals 6. I have 6 H's on this side, and then I only have 2 H's on this side. What do you think I should do? Well, if you said put a number right here, you're right. What number should I put here so that I have the same number of H's? So remember, I have 6 H's over here now. What number should go right here? You're right, 3. Okay, so now I have 2 N's, 2 N's. 3 times 2 is 6 H's. 2 times 3 is 6 H's, right? That's a balanced equation. Let me give you another one. Maybe I'll have you try to do it at home. Let's see. 2, 3. C yields Fe plus CO2. Okay. All right, this is my equation. I want you to pause the screen right now, and if you can't read it for some reason, maybe you can't read that. And if for some reason it's backwards, because I know it looks backwards to me, hopefully it writes itself for you. It says Fe with a subscript of 2, O with a subscript of 3, so those two go together. So anything you write in front of this is going to be written for the whole thing, for this whole section. Fe2O3 plus C yields Fe plus CO2. Okay, so, and by the way, anything on this side are called our reactants because those are the things that react. Anything on this side is called our products. So that's what because reactants react to produce products. And so what I want you to do is pause your screen, if you can see it there, and see if you can figure out what numbers need to go where. You have 4 spots you can put it. You can put it before here, maybe before the C, put it before the Fe, put it before the CO2, and it affects everything in that section. See if you can, again, if you rewrite it on a piece of paper, if this is backwards, it looks backwards to me. Hopefully it's righted by the time that the video flips itself. It's Fe2O3 plus C yields Fe plus CO2. Pause the video and see if you can get what it is. Okay, I'm assuming you paused and tried it out. If you didn't get it, that's okay. All right, so the first thing you notice is that the FEs are different. Okay, this one might be. Let's hope this is an easy one. Let's see. The FEs are different. Okay. All right, this one's a little bit complicated, but let's try it. So what can I do here? Well, I have 2 FEs here and only 1 here. So let's start just by putting a 2 here for now. We may end up having to change that. Okay, so 2 FEs and 2 FEs. Okay, good so far. But let's go to O. O3, O2. What can I do? What can I do? My phone just rang. What can I do? Well, since this is O3 and this is O2, let me multiply this by 2. It's a 2 in front. And then we multiply this by 3. So now my O's have fixed themselves. I have 2 times 3 equals 6 O's. 3 times 2 equals 6 O's. But what did I do to my FEs? Oh no, now I have 2 times 2 equals, I have 4 FEs now. That's okay. I can just change this one to 4. There. Now my FEs are fine. 2 times 2 is 4. 4 times nothing, and 4 times 1 is 4. And then my O's are fine. 2 times 3 is 6. 3 times 2 is 6. Okay? The only thing that's off now is, look, I have 3 C's. Well, I just have a C here, so what I can do is 3. Now it's all balanced. I have 4 FEs, 6 O's, and 3 C's. See, that's called a balanced equation. Your older brother or sister, if you have one, probably does this in chemistry. Maybe I will see about giving you a simple worksheet to see if you can do that. Balance some equations. But anyway, remember the things in the front are called reactants, and they react to produce products. The last thing we're going to talk about on page E72 and E73 are signs of a chemical change. There are 4 signs of a chemical change. And this is something you need to remember. 4 signs. Something has gone through a chemical change if a color change has occurred. Okay, so if it changes color, like that tomato I used as an example at the beginning, if it changes color, like green to red or something like that, or in that picture right there, that's a chemical called iodine. You might see somebody get, iodine, and I think do they use iodine in your eyes when, I don't know. You get iodine, sometimes gives like a yellow stain to your hands or whatever, but there it actually turns black in the presence of starch. It turns black. You can see that iodine there. Or the blueberry juice and baking soda causes a change in color. Anything you add one substance to another and they change color, that's a chemical change. So the first one's a change color. The second thing is a formation of a gas. When you put 2 things together and they release gas, what happens is one of the products, when you put all the things together, you'll get a product of, like in that previous example on the page, you have baking soda and acetic acid together equals water, carbon dioxide, and sodium acetate. The carbon dioxide is actually given off as a gas. You're left with water and sodium acetate in the dish, if you will. And then you'll get carbon dioxide gas coming out from it. And so that gas is evidence of a chemical change. Fun little extra experiment that you could do if you happen to have a balloon lying around and some sort of bottle, maybe like a bottle of soda or something that's empty. What you can do is you put some vinegar in the bottle. Put vinegar in the bottle, just a little bit or whatever, however much you want. And then you take baking soda and you put it in a balloon, and you wrap the balloon around the mouth of the bottle. Don't let anything come out yet until the balloon's secure. Okay, so the baking soda in the balloon is kind of hanging down. You wrap the balloon around the mouth of the soda bottle or the water bottle or whatever you're using. So again, the vinegar's in the bottom of the bottle, and baking soda is sitting in the balloon. Wrap the balloon around the mouth so it's nice and secure. You might want to hold it. Then you tip the balloon up so that all the baking soda falls in. When it falls in, it's going to release carbon dioxide gas, and it should blow the balloon up at least a decent amount, because what's happening is that exact reaction that we see there, that it makes those acetic acid water and then it releases carbon dioxide up. That's a nice little safe chemical reaction you can do at home. Also, I'm sure you've seen Mentos and Diet Coke. That's a chemical reaction. You put Mentos in Diet Coke and it goes, don't do that inside. If you're going to experiment with that one, that's an outside experiment because it gets everywhere. But that's a chemical reaction that gives off gas. So chemical reactions: color change, formation of a gas, formation of light. Sometimes a chemical reaction occur and you have light come from it. And formation of a gas, formation of heat. It's combustion reaction. So a color change, a formation of a gas, giving off light or giving off heat. When you have chemical reactions, sometimes like those little packets. You see Mrs. Crone sometimes uses those hand warmer packets. You pop them and puts them in her gloves. And I don't know if you've ever done that, pop them. That's actually a chemical reaction going on. And that chemical reaction, one of the byproducts that comes from it is heat. And so there's a reaction to a couple different things form, and then plus gives off heat. There are many byproducts that can happen from a chemical reaction. When you burn wood, burning wood is a chemical reaction. One of the things it gives off is carbon in gas form. That you see the ash, the smoke coming up. That's the black smoke is actually carbon in the smoke, carbon going up, and that's a byproduct is that carbon. That's why the wood gets kind of blackened with the carbon. So that is that's pretty much it. It talks about some familiar chemical changes like rust. Rust is actually a chemical change. Rust isn't just like a stain on the iron or the metal. Like if you leave your bike outside, rust isn't just like a stain that you can just wipe off. Rust is a chemical reaction. You can't. It's when iron gets in the presence of oxygen, and iron oxidizes and forms rust. You can't reverse it. And so the last page there talks about what's easier to reverse, a chemical change or a physical change. Obviously, a physical change is a lot easier to reverse. Even if you ripped a piece of paper into 1,000 pieces, it's still paper, right? You can't reverse, like if you burn toast. You can't make it unburnt again. It just can't happen. So that's our science lesson for today. Maybe I'll see about giving you some of those if I have a chance. I'll give you some chemical reactions to try out. All right, bye.